Thank you for joining us this evening. You were brought into this conversation with your microphone off and your video off. If you have questions, please put them in the chat. Megan will gather them up and ask them at the end. You're welcome to make comments as well. We have a lot of location data coming in. I'm Jennifer Dye, a librarian at Detroit Public Library. This program will be recorded and it will be made available on the Detroit Public Library YouTube channel and through the Wayne State University's website. We've had astronomy programs for several years. Before the upheavals of 2020, we met in person. And when things fell apart, we put programs on hiatus. We finally launched astronomy programs in Zoom in early 2021. And we've been working with Megan McCullen for the last several months. She is director of the Wayne State University Planetarium. And she helps us with everything. I'm very grateful to her. But she also connects us with Wayne State faculty and alumni and students. So we'll continue our past practice of presentations by members of local astronomy clubs, but we look forward to working more with Megan and the planetarium. In our program next month, Sean Gavin, Associate Chair of the Department of Physics and Astronomy at WSU, will tell us about the agreements about what science proved about the age of the sun in the early 19th century. And that, I'll put that in the chat. And at this point, I would like to ask Megan to speak briefly.
Thanks, Jennifer. Yes, thank you all for being here and for joining us for this. We always like these events, and thank you, Jennifer, for putting them on. I get the easy part of this job, I feel like. So yeah, thanks for doing that. And yes, I've seen Dr. Gavin talk about this before. It's actually the arguments, not the agreements. I believe.
Oh no, I didn't mean to imply that there was agreement. There were a lot of arguments.
Yes,
and
it's a very
the
good
science proves whatever.
Yes, the debates and arguments. It's a fun one. So I definitely recommend that. And then I'm going to put a few links in as well to some upcoming events that we have going on at the planetarium. We have started doing some in-person shows as well. And so I will post the link to our Eventbrite page. And then for the Wayne State students, faculty, and staff, we also have some shows that are exclusively for them that are on the Wayne State events calendar that you can register for there. So I'll post those up. We're going to be at Noel Night this year. Noel Night is coming back, so that will be great. And then I think those are the only events I'm going to post right now, but we did a great event out at Belle Isle last week that Adrian was able to help us with. So thank you, Adrian. And we're hoping to do more of that. That was our second Telescopes on the Island event. And both of them went really well. So I think that's going to become a semi-annual event at the Nature. So for those of you who are in the area and would like to get out and try to shoot the moon from Belle Isle, you'll be able to do that. And I will stop there.
All right, well, thank you, Megan. Adrian Bradley is an officer of the Warren Astronomical Society, which is actually where I met him. And he is an avid astrophotographer, and maybe I'll be able to say that straight. He's presented for us twice before, and they're always informative and beautiful. I love his images.
I appreciate it.
So Adrian, thank you for joining us.
All right. Well, thank you all for coming. The topic they wanted me to talk about is shoot the moon. And the sad part about the presentation that I want to do is that there are a couple of moon images that I have shot that I really like, and I'll probably just use part of the presentation to find them. So when we say shoot the moon, for astrophotographers, there are a couple ways that we do it. I'm going to be showing a series of images and just sort of talking about the process behind them. But before I do, I'm going to show the equipment, or at least the camera equipment that I use. This is a 35-150 lens on this A7R4 Sony. The point of showing you this is that if you are into photography out there and you have a lens like this, you can get some pretty decent moonshots. And I'll show you, when I show the shots, I'll show what I took them with. The majority of my pictures are with, including the one behind me, are with a lens, this lens here, a big old, and it's not showing up too well because of the moon picture, but yeah, I think you can see it here. It is a 150-600. So if you all are wildlife photographers, your camera almost does not matter. You can get pictures of the moon. I do recommend a tripod. And I actually recommend, for those that know about aperture priority, to use that as your base setting to see if you can get a moon photo. Now, so what I'm actually gonna start with one of our hosts, Jennifer. If you come back on and disappear from your screen, you've got the moon photo, the first moon photo that I've had trouble finding that I would love to share. What you're seeing on Jennifer's screen is a shot that I took, and I'll look for the original picture. This is a thin crescent moon with aperture priority. It looks like a full moon, but with a bright spot right here. As it turns out, with aperture priority on a tripod, you can expose the moon enough to where you can see the full moon with just the lit part is bright. And there are techniques to get the rest of this moon. You can do a composite if you want and get the rest of the craters in the moon and have the whole thing a little more complicated, but a lot of internet astrophotographers will take the time to take the extra shots to make that happen. And so now I am going to go ahead, find wrong folder. I will find pictures that I've gathered and share my screen. The screen right here, share. And here are some of the pictures that are slices, examples of the different ways that you can shoot the moon. Now, most of us are familiar with just a big old full moon. No matter what moon shot you take, it's, no matter what type of moon, this is basically the moon that you see with your eyes. Now, somewhere, let's see, this one, which is a waning moon. Okay, this has a little more detail, but you see this moon as it's waning. You see other crescents as it's waxing. If you're trying to get a particular moon at a particular phase of the moon at a particular time, you have to check some applications. You can check, I think PhotoPills may be one of them. I think I use a different application. I use called Sky Safari to see when the moon's rising. I can look in and see what phase the moon will be in. So I've shot it in just about every phase, including the rising moon, which is very hard to do. This one, I tried to make it look the way I saw it as it's rising over Lake St. Clair. I got a decent clear picture of this, but it made it kind of look like a poached egg there. So sometimes your attempts to get good shots, you end up having to do 2 shots and then blend them together. And then with this one, had I done a better job of blending the moon here with Earthshine, I think it would be absolutely fabulous. I do have an image I'll show you, and I know where to find it. So I'll be doing this from time to time when I think of an image that I've shot. A lot of moonshots, if they don't turn out okay, they end up being practice shots. And you can always, let's see if I did them here. As you can notice, this one, let's open that one up. This is an example of shooting the moon. There's two things that I hope to show you. You can shoot the moon by itself in whatever phase it's in, look at all the craters and enjoy that. Or you can try and compose the moon in some sort of scene. It was raining. I had to cover the camera because it was actually raining when I took this photo, and the quarter moon appeared here. And it says there's a little bit of a halo here too. And it just became a part of the scene. So astrophotographers, astronomers, visual astronomers tend to say, oh, the moon makes it too bright. You know, if I show you this picture where no moon is and you can see all the stars, this is here at Point O'Bark Lighthouse Park. More astronomers prefer an image like this, but part of the reason I started to take shots at the moon is because I wanted to incorporate the moon as a part of the sky and try and take good pictures with it, because it doesn't go away. So we may as well use it for, you know, whatever. May as well see if we can get good shots with it. And here we go. This is another example. So here's an example of shooting just the crescent moon itself. When you're going to see this moon in a few days, maybe 2 or 3 days from now, you're going to look in the sky and this thin crescent's going to be here. But when you see that thin crescent, it may look a little bit more. Let's pick one of these. Let's pick this shot. So I'll close that up. So here we are. There's the radar dish. There's the moon, a couple of stars. And when you look at it, you'll notice this faint part here, and you'll say, wait, am I seeing, you know, are you seeing the rest of the moon? Yes, you are, because Earthshine actually casts the light onto that part of the moon that isn't lit by the sun, and you can see a part of it. So fortunately for me, I found this folder because I took this picture, and there you go. This is the crescent with Earthshine image, and those stars show up. Those are actual stars. The only reason you can tell, because you've got some that are larger, some are smaller. If it was just noise, it would all be the same size and it would just be grain. You've got a moon, a sun hanging in there with some stars. I do love this photo. I'm rediscovering it. The fun part would be if I had taken this picture alongside, let's go back to the folder here. I think I tried to do that alongside the dish. So here you go. You've got the dish, you've got the moon, you've got stars going around it. Now, unfortunately, the tree, I lost the trees when trying to process it. So those are some of the challenges you have. When you're trying to pair the moon with an earthly object, you can run into those challenges. And let's do this here. So now we'll go back and let's do this. Sometimes it's part of a total eclipse. There goes some more stars. This was the recent 97% partial eclipse. This is what the moon looks like. And a lot of astrophotographers will come out and shoot the moon when there's an eclipse, because you've got that unique red color, which gets created because if you were on the moon looking back, you would see a reddish hue coming around the Earth. I wish someone had the ability to take the picture of it with the lunar orbiter or something. You would see that the reddish, basically the colors of sunset going around the entire Earth. The Earth would have blocked the sun, and it's essentially a solar eclipse. According to, if you're on the moon, the Earth blocks the sun, makes it into a solar eclipse, and that red light is cast all the way from the Earth of some 200,000 miles to the moon and gives it that red color. It gets so cold here that supposedly the Lunar Reconnaissance Orbiter shuts down, doesn't want to perform any extra functions because it's so cold during that time. And that was I won't call it an excuse. I mean, if you don't want to lose your Lunar Reconnaissance Orbiter to being frozen, but apparently the temperature gets so cold during a total lunar eclipse they can't operate it. Otherwise, I'm sure we would have pictures. And if any of you have seen a picture from the moon during a lunar eclipse, then I would be more than happy to have you refer me to it, because I think that would be an amazing sight. As the moon is being eclipsed, and we'll go into that, you see things like this, where there's a little bit of a darker shadow here, and the shadow of the Earth is starting to cross over. So we're kind of going backwards. This part is completely lit by the sun, but this part is starting to, so you have penumbra right here, and then umbra where you've got shadow. It starts to eat away at the moon more and more. Then it gets here. And as you already saw with this particular eclipse, then this begins to glow. And all of these shots were taken, again, with that camera that I showed you earlier and that 150 to 600 millimeter lens. The only other thing that I use during lunar eclipses, I will put it on what's called a tracker. And I'll see if I can bring that in. Let me see what time. It's almost half an hour. This little thing goes on top of a tripod, and you use it, and I've got the ball head mount to mount on there. You use it to follow the sky and counter the Earth's rotation. I use this for Milky Way photography as well. And you use it to track the Earth's rotation so that you can focus on the moon if you want to expose it for 2 or 3 seconds. Lunar photography, when it's being eclipsed, often you can't just pick up the camera and take pictures. A lot of these pictures I've taken are handheld, but not all of them will work like that. As the moon is slowly coming back from eclipse, the Earth's shadow goes in a different direction, and when it's all over, you're finally back to your regular full moon. And see if there's any others. There is one other image. I'll share a couple of other images. This is an image of the moon and how how it looks against the stars when it's in eclipse. And this was taken about 30 minutes or 30 to 40 minutes away from Port Huron on the lower eastern part of the state. Maybe a little closer than that, maybe 20 minutes. And there's a star cluster there that it's near. Anytime the planets tend to go near this little star cluster, you may see some pictures where someone completely exposed the gases and nebulosity here, and threw the eclipsed moon under it in this spot and said, this is, that's the image. Another way to look at it, if you're looking at it at night, here you have the stars, you're looking up. It's a little exaggerated because it's 2 images again. So the eclipsed moon still cast a pretty bright light, but there it sits in relation to the stars here. And so when you're, think November 8th of this year, which happens to be my birthday, but it's also, there's going to be another one of these lunar eclipses, and it's going to be total. And we should be able to see it here in the Detroit area. Now, from your part of the world, you may need to check to see if that total lunar eclipse is visible in your part of the world. For instance, India, I'm not so sure if it's going to be visible there.
Adrian, I just put a link in the chat to a list of lunar eclipses that shows you.
Oh,
the world
excellent.
chart. So it's like we were on the same page.
Yeah, excellent. So now I'm hoping to get lucky and find a couple of other lunar images. I did find this one. So now you can see the full image that I took that night. And again, this is a sort of imaging that I like to do with the moon, not just, you know, shooting the moon directly, although I do have some of those. But this picture, this is sort of an area that's kind of become a nature preserve, not far, maybe, you know, less than a few feet from where I live. And I saw that moon up there and I said, why not? Let's take a picture. So this is sort of what I saw. You've got clouds and you've got that moon hanging out. And then I took a closer shot. The one nice thing about shooting the moon, you do not need a dark site to shoot, but that's a perfect segue into some of the images I picked out here. If you are at a dark site, let's take a look at this right quick. Moon reflections, another part of composition that you can try. This looks like a big old dinosaur footprint, but it's a mud puddle, basically, where I was. And with trees, you can try and compose. This could be your Christmas card if you love the moon. If you want a picture of that, let me know. And here's the moon. This is the rising full moon as it's still light enough. It's dusk. The moon at dusk offers a lot of compositional opportunities. And you can shoot with the Milky Way if you shoot at the right time. So let's show a couple panoramas. Milky Way photography is something I enjoy doing. And in this particular time, you have moonrise. This is just about how the scene looked everywhere, including that fog in the distant part of the lake. But even though you have Jupiter here and Saturn, this is back in June or July when we had that lineup of the planets. So Jupiter, Mars, Saturn. And more planets were going to rise later. I stayed the whole night to get that, and I'll show you what I got. But the moon's blown out, and it's like, so how do I get a picture with the Milky Way and the moon? I'm not so sure I did a good job of doing that on this particular go round. Let's see. So we have moonrise. So this was earlier in the night, or the Milky Way is a little bit more pronounced here. Clouds generally don't stop you from taking pictures of the moon. And more pictures of moonrise. I'll get to that one later. Let's show the parade. So here is a composite where I tried to combine the moon. There were some mistakes here, but you've got Jupiter, Mars, Venus. You can barely see Mercury right here. And you notice they're all in a line. They're all on the ecliptic. Here's Saturn over here. And there was another star. Yeah, this little star right here is actually a star named Fomolo. But there's Saturn. That was the planetary lineup. And here we go. There's Mercury, Venus, Mars, Jupiter, a star here, Saturn, and the last quarter moon. So you may recall everyone was looking for images of the planet parade. This was my contribution. And as far as the moon goes, you could still get all of those planets. This was a composite shot, but the original shot contained everything except the detail of the moon. And I tried to paste it in. I ended up with this tuft of hair on it, which is not natural. This area here is the bright moonshine that I tried to blend out of it. But if you look at the detail on this moon, this was the last quarter. Some of it's missing because of the way that it came in, but you can still see crater detail. Again, taken with, and I think this was taken with that 35 to 150. So you don't have to have the biggest lens to take moon photos. And so we'll drop some of these more Milky Way photos here. And let's see, I covered compositions like this, where I have a tree and then I try to lay in moon detail so that it looks similar to the way that you'd see it. And it's something I've continued to work on. I've also continued to work on doing compositions where it looks like something on the earth is interacting with the moon. And this was while I was out west. The moon was setting behind a big mesa over here. So I zoomed in, that's with the big 600mm lens, and caught this picture using aperture priority. I noticed that it looked like this tree was holding the moon up. Those are the sort of moon compositions you may have seen on the internet, with people holding the moon or appearing to hold the moon or appearing to put it in the trunk of a car. They'll do the same thing with the sun as well. So those are, when shooting the moon, for me, it's not just enough to have all of these, and these are beautiful shots. Even if I took them, seeing the craters, seeing the shadows, it's an excellent thing. I'm looking because one of these images, there's some features that I want to point out. Notice how that looks kind of like an X. There's a certain time in a first quarter's life, we'll call it, when these craters form what looks like an X based on where the moon shadow is. And up here, that looks like a V. Those actually have, we'll call it a colloquial name because I don't remember what the actual crater or rims are called. But that's something that all of us can look up. But you will also find, if you look up lunar X and lunar V, you'll see these features on a quarter moon. For those who, and they probably stick out now, those who love shooting at the moon and have several shots like to go for these little things that that show up. I actually took the picture after looking at it in the telescope, and I noticed that I could see the lunar X and the lunar V there. I instantly picked up my camera. That's a handheld shot. Image stabilization in the lens or the camera can help you get a good shot with, even though you're holding it steady, you can get a sharp shot. This was a failed attempt. It's still the quarter moon, but it was a failed attempt. And whenever the left half of the moon is chopped off, it's waxing. It means it's growing into a full moon. When the right part is chopped off, it's a moon that rises later and later at night. It's called the waning moon because it's getting smaller. So we'll do a quick quiz and then break. Is this a waxing or waning moon? You can type in the chat which one, for those who may not know. If you already are familiar with waxing and waning, then you've got the advantage. And I'll pick another picture and you can tell me if this is a waxing or a waning moon. I'll talk about the picture a little bit. This is hard to do. I'm at night. This thing is rotating around and the moon is over here. And I want to present an image that looks like what I'm seeing. Well, how do I do that? I've got to take a couple of images and then I've got to blend them together. So I took a moon image. So there's you can see the craters on it. And then I tried to blend it in seamlessly with a picture I took where I actually stopped the blade's motion with the way that I use the camera settings. I believe I did put it on a tripod and I took a quick photo. It wasn't enough to stop it completely because we're at night here and we're only illuminated by the moon, but I was able to stop motion. I tried it again with 2 windmills. It was even noisier. Those of you that are familiar with noise and trying to get rid of it will notice that it is noisier, but the idea that I tried here was, can I stop motion on a windmill, have the moon, and present an image that people would see if they were there with me? So shooting moon photos, that's definitely part of the process. This is what the moon looks. If you've never seen moonrise over a lake, this is what it looks like as it's coming up. It is a quite beautiful thing. Let's see if I'm going to look for, because I've done some other presentations and shown some of the moon pics. I'll open it up for questions because I know I've gone on for maybe 35, 40 minutes. So if there are some questions, go ahead and read them and I'll answer them to the best of my ability.
Yeah, I've got a couple different kinds of questions for you, Adrian. Some
Okay.
are about the photography and some are just moon facts. So don't know if you know them or not, but we're going to throw them at you.
No problem. And if I don't know, I'll either do a quick Google or I'll refer you to what would probably be a good source.
One of them was just about the moon phases. Are
Yes.
they the same everywhere on Earth?
Yes,
All right.
they are.
That's an easy one then. And then what is Earth shine?
Earth shine is when the light coming from reflected light from Earth hits the moon. Now, I have always thought that it was city light, but I believe I am wrong. So really quickly, the way we find out, Earth's reflected light in the dim glow. So what I was looking for is whether or not it's the city light. What it really is it's a full Earth from the moon. This is what it's telling us. And that sunlight bouncing off of the Earth is what's causing that shine, not our cities or anything like that. So new moon is full Earth. So if you think about it that way, and because the Earth is bright at full Earth, it's casting that glow. Much like the moon at full moon casts more light at night on us than it does when, at this phase, it's a new moon. So we aren't getting any reflected light, but we're the ones reflecting the light back to the moon when it's Earth shine. So there is your answer.
There's a question in the chat right now about a 10-inch Cassegrain, and they want to know if there's a video that shows how to attach a scope to a 35mm camera.
Well, I'll give you the things that you'll need. There are videos on YouTube on doing this, but say if you have a Cassegrain, and more likely it's a Schmidt Cassegrain or Microsoft Cassegrain, which is it's a design. Those names are the people who help design, starting with the Cassegrain design and added to it so that it could be a shorter tube. True Cassegrain is long and big, but you would need something called a T adapter for your specific type of camera. And that T adapter connects, screws onto a diagonal that you have for the Cassegrain, or onto the telescope itself, and the camera connects with an adapter to what's known as that T adapter on the camera, and then you end up with a connection, and your camera essentially becomes like an eyepiece. You have to focus your telescope. If you've got live view on the camera, you can look at your live view and see when things are in focus. Once you do that, you can start shooting either the moon, which a lot of top astrophotographers do mosaics, so they get even more incredible detail than you can with a regular camera. Or if it's a wide enough field of view, you can just take a whole picture using that telescope. So that should get you started. There are videos online on how to connect it. It depends on your model Cassegrain or your type of telescope, whether or not. A lot of them will come ready made with a T adapter so that you can put your camera on it. Otherwise, you can order those parts from an online store like High Point Scientific. Explore Scientific may have it as well. Ordering them from a scientific site and then making sure you get the right one for your model of camera. So any other questions?
Yes, sorry, I was still muted. I didn't realize. I was asking you a question. Relatedly, what did you say the thing that you used to help you figure out or to get the telescope to move with the Earth's rotation? You showed it to us.
Yeah, it's called a tracker. It's
just a tracker. Okay.
Yeah, just a tracker.
All right, that's easy.
Yeah.
Okay, if the moon was formed from a collision with the Earth, why didn't it knock the Earth off its orbit, or is that theory wrong?
Well, that's a very good question. And what we would have to look up is whether or not it truly did knock the Earth off of its orbit. It certainly affected its spin. The Earth's orbit as it sits today may not have been the orbit that it had when the planet crashed into it. And again, that is the prevailing theory of how the moon got formed. Other theories, such as capture of the moon, it was its own planet, but the Earth captured it and now it's in orbit. That's still out there, but the most accepted theory has been the Theia crashing, glancing below into the Earth. It wasn't, and that's the other thing, it wasn't a full smack collision, or both would have been completely destroyed. It was a glancing blow that where the Earth continued to exist, but had its mantle knocked off, its crust knocked off. All of those pieces form a ring around the moon or around the Earth, and those pieces coalesce to become the moon. So that's the other thing to consider, is that this is a glancing blow, so it wouldn't have knocked Earth completely out of the area of orbit around the sun that it was in. So that's there's more that you could look up for the topic to see, you know, I'd have to admit that I'd be guessing to you to say such a massive collision should have at least moved it a couple of degrees, you know, off of the orbit, but space is really big. So, you know, the point that Earth is in does change. It's not a completely circular orbit. We're heading to where it's actually going to be, let's see, winter. It's actually the closest to Earth is closest to the sun, but because in the northern hemisphere we're tilted back, southern hemisphere tilted toward the sun, so summer, and it's closer to 92 point something million miles. During our summer in the northern hemisphere, it actually is around 94 million miles from the sun. It varies as it goes around, but we're still able to feel the heat of summer. And why it's still 70 degrees at this time in October is up for debate. We won't spend a lot of time on climate change here, but as far as the moon's concerned, it's still close enough to affect tides and affect weather. About 65 million years from now, it'll move the distance. The center will move a distance of I believe a Chevy Cavalier. So the moon, that's another, I don't know if it's another question in there about, is the moon moving away from us? Yes, but it's processing at such a slow pace that it's going to take the same amount of time the dinosaurs have not been on Earth, other than birds, to move, you know, the distance of a car. And so you're not really talking about losing the moon until millions and millions of years from now. So we went a little too far with, we added some things to that question, but
that was good. It was a question from a 14-year-old who happens to be studying for an exam at the same time. So I think that was all good information to pass on to them.
Excellent.
When you are doing when you're shooting the moon, how many photos do you think you take in a given night, and how long are you out there typically, or does it vary?
So let's take this one, for instance. If I'm trying to do something like this, where it's a sharp moon here and there's stars over there, 21, 22 pictures of just this scene. Once I get it right, I think I have all the elements I need. Then I go back home and then process them. This particular night was very likely, I'll say, about an hour's worth of time that I'm out there. Now, if I'm getting a quick shot of the moon like this is all of about 10 seconds and I'm done. I'll take maybe 5 or 6 shots. And as soon as I get one that's sharp like this, and this has actually been converted, but I've gotten them even sharper. As soon as I get a good one, I'm done. If I happen to have my camera with me and I notice the moon is in the sky, you know, I'll try and take a picture. This is one where I feel like I overprocessed it, because instead of stars here, you've got grain. But yeah, so 10 seconds for a quick shot directly at the moon. It could be an hour as I try and make a compositional. This was the same night as this photo that I tried to do and this photo that I tried to do. So it takes a while, especially when you're experimenting with your moons and you're trying, you're going for certain things that you're trying out new and interesting things with the moon, and whether you can capture Earth with it and things like that. And there are a lot of there were a lot of attempts to do things. For instance, the crescent moon here, I've taken it a few times. It also depends on when you're trying to shoot the moon. So the question to the audience is the moon in this picture? The answer is it is. That's the sun during a partial eclipse. That's the moon, which is slowly moving this way, leaving at. I went somewhere where I could see as the moon rose out of the clouds, I was able to see the partially eclipsed moon. This is a little earlier in the day. And I think this image, as it peeks through the clouds, you can see that part of the moon coming out. It really depends. So the answer to the question, it really depends on what type of shot that I'm trying to get with the moon, and what is it that I'm trying to do. So
it's interesting you just showed the solar eclipse. When you mentioned the lunar eclipse coming up, apparently there was just a partial solar eclipse yesterday in India. So they got that. They don't get the lunar eclipse, but they got the
partial solar eclipse. I think the UK may have gotten a part of the solar eclipse too.
Cool.
So it was I think it was just a small part of it that was visible. Do you know if more of it was visible at different parts? I mean, as sometimes a lunar eclipse a total solar eclipse is only visible out in the ocean, depends on where the shadow, or it's off Earth somewhere. But I'd be curious as to where the totality might have been viewed at.
Yeah, I'm not sure.
If there was.
I can try and take a look while you're answering other questions.
Okay.
We have one in the chat right now that says, is there a good amateur camera to take great pictures like these, or looking for the feature is more important?
Any DSLR that's come out within the last 10, 12 years is a fine enough camera. The key, I think, is magnification. At 400 millimeter, you begin to basically your optical magnification. The closer you get to the moon, the more detail you can pick out in a single shot. So at 400, you can start to get sharp details. 300, 250, 200, you can get some details from a distance. If you zoom in, you start to lose it. You're not seeing the lens I'm hanging up. You're seeing an image, taken with the 600 millimeter lens and then edited to show color that you normally don't see with your eyes. But it's determined that those colors actually map to certain minerals that are in those places on the moon. The rust looking color is in fact iron oxide. It's rust. The bluer parts are titanium. This is something that a lot of astrophotographers like to present the moon as a mineral. They call it a mineral moon because they get to show off processing skills. And as it turns out, NASA's confirmed, either NASA or JPL or, both organizations have confirmed that that's actually mapping out where the minerals really are on the moon. So it's a thing. It's more of a processing trick, but it's also, it also has some science behind it. To answer the question though, the larger the lens, the better if you're going to do single shots, the better your details get with a larger lens. Here we have another one of my mineral moons waxing, and a couple of another feature, the golden horn or the golden handle is this feature over here, which again, it's a sunlight thing. it's and during this gibbous phase, this shows up. It looks kind of like a handle. And if I didn't play around with the processing on it, it would have a bit of a golden look to it. So yeah, so to answer the question, to be labeled the answer to it, the larger your lens size, the more detail you can get. Now you can take this sort of picture with clouds. I don't think this was a composite. I believe this was a single shot. And it was done so that I could illuminate the clouds and the moon around the clouds. A little tougher to do in a single shot, but we pulled it off. And you can do that with a lesser lens, but I've done it with a DSLR or mirrorless camera and a big lens. And that's the only other way would be through stacking moon images using a small telescope. You can do it that way. It's a little more tedious, but you end up with a lot more detail in your moon. So there's the quicker way becomes to own a camera. There are some smartphones that have started to get some moon detail, and I've noticed some of those smartphone pictures don't look bad at all, but there are some, I'll say there can be some issues when you zoom in, and that's the key. If you want detail where you're zooming all the way into the moon, that's when DSLRs are important. But as you can see here, not all moon photos have to have detail if your focus is on something else. This picture, laying the camera down, using the light of the moon to capture these rocks, and then the lake, this is Lake Huron, blurs out on purpose. This is one of those perspective shots where I'm not going for anything science. It's more aesthetics. It's a pleasing photo. I looked and said, let's try it. Let's see if we can get. Also, I found some of the photos I tried to take where you can see the Milky Way fading here as the moon rises. This was an attempt to be the way the eye sees it over this part of the lake. It's close. I did a better job of smoothing out the moonlight here, and there is detail, but I believe it's a lot more orange at this phase when it's coming up.
I looked up the solar eclipse, and it was only a partial eclipse at all because the angle of our orbit right now,
Okay.
everything. So the maximum of the eclipse was about 80%. And it looked like I think it was Russia and Kazakhstan got the best views.
Okay, so totality was off Earth then.
Yes,
which is that happens.
Mm-hmm.
So here, this is another, as the moon is rising, you see the Milky Way fading. The goal of this particular night, and I thought I had, I have one right here, was as the moon rises, get the Milky Way and sort of chronicle what it looks like. So it is possible to shoot the moon and the Milky Way at the same time. A few of the images that I have here are of me doing just that. And let me find this one. I'll always be rather proud of because it's a full moon rising. I got lake detail. There's more I can do here to make it even better. This was shot 250 millimeter lens. So this is the sort of thing where it's close to what you would see if you were standing over the water and looking at the moonrise. Once it gets up here, it begins to lose that orangish color from being low on the horizon and begins to shine brighter, bright white.
I have another
Right.
moon question for you.
Okay.
Why do we always see the same side of the moon?
Because the moon is tidally locked to the earth. Orbital mechanics, there's basically a certain point at which an object orbiting around another object becomes tidally locked. The amount of spin it'll have, it rotates as far as the sun goes, but it will always, that part that faces the earth always faces the earth. It's about where it is, how close it is to the earth in its orbit. So there's more information on how tidal locking occurs that I don't have, but it does have to do with its distance. If it were further away and rotating, one, our tides and our earthly tilt would be affected. Two, it would be possible for it to rotate without being tidally locked, and we'd end up seeing some other phases. If we were close enough to the sun, of course, we'd probably bake alive and that would be it. But it's possible for the earth to be tidally locked to the sun or any other planet if it were close, if it forms and ends up in an orbit that is close enough to where the influence of the sun's gravity, we'd have an earth that rotated around the sun and the same part would face it. They've seen this in exoplanets where exoplanets are too close to their host star and they end up tidally locked. So one side is constantly burning and the other, it's just taking on the full brunt of the sun. There's always day. The other side, there's always night. And there's this little sliver where it's neither day nor night, which could be possibly habitable because of the temperature. So it's so it depends on how close the smaller body is orbiting the larger body.
All right. My personal question for you, this is the last one I think we've got, is when you did go try to take photographs out on Belle Isle of the moon last year, how did that work? I didn't actually get to hear your results. Is it any good?
They worked.
Yeah.
Yeah, I was looking for, yeah. So that's actually the moon setting through the trees here as the Milky Way comes out. We did that in, was it July that we did that event or was it June?
I think it was June. It was supposed to, it might have been May. It was supposed to be April, and then we had bad weather.
I remember how the moon looked. It didn't look quite like this, but it was close. I would have to look up the date, but I can guarantee you it would look something like this.
Got it.
Because it's very, all of the moon shots are very, very similar. I don't think this was, no, this was mine. I was in Vegas and I happened to catch the total lunar eclipse coming out of the clouds. There go mountains. It was right before I had to go bowl a tournament, and I went to the roof of a parking structure at South Point Hotel and shot this and sent it to be shared around the world, basically saying this is what totality looks like from a part of Las Vegas. So,
but that's good to know. So I can tell
Yeah.
people if they ask, yes, you can take good photos of the moon from Belle Isle.
Yes, you can. The moon is bright enough. The key is that the moon is bright enough that taking pictures of it from almost anywhere is just, it's not a problem at all.
Yeah.
So as you see me going through, this was actually a dusk time moon and it turned out pretty well. This is one of the sharpest moons that I've ever taken. As you can tell, because I'm zooming in
Wow.
and you're seeing features of the moon. Same gear, just more care taken. This is about where it begins to fail, right? Still not bad. Look at the mountains here. This is where Apollo 15 landed. Over here, let's look for Apollo 11 in this area and Apollo 16, I do believe, over here. Apollo 17 in a clearing somewhere here. This moon was not full. Apollo 12 and 14 were over here. Trick question, where was Apollo 13 supposed to land?
Supposed to land.
Yes, that's probably too
I was gonna
tricky.
say that's
It's too, it
I
may
got
be too tricky a
distracted.
question, because
Yeah.
what I'm getting at is that we did land a mission where Apollo 13 was supposed to. Apollo 14 ended up going where Apollo 13 was supposed to, which is
Okay.
somewhere over here. Apollo 12 and 14 were close together. They were beginning to explore this part of the moon that you can't see
Yeah.
in my image. But if anyone has a question, what is the clearest moon image I've taken? That would be about it. Taken in April of 2022.
Nice. That's awesome. Well, we're just after 7, so Jennifer, I don't know if you want to wrap it up here.
We can. Does anyone have any more questions?
Related to
Do
the
a couple
moon or
more.
photography.
Yep, for those who,
These are great.
yep, those two were also, and this, you've seen this one already, so we'll close that one down. Just looking for any other.
Do you have a bucket list place you want to take moon photos from?
Maybe not, but I did have an idea for moonrise. I wasn't able to do it this year, but I'll see if I can find my there's one last photo I'll share. Was it this? That's just total eclipse. At some point in September, the moon rises in the middle of the zodiacal light, and I will find and I think I know where to find it. It will be, that's Peach Mountain. There is a, if I can find it, I'll stop sharing until I find it, and so I can answer more questions. If I do find it, I will I'll share the image I got, but the goal, not necessarily a place in Oklahoma, I'll be able to see it, but let's see, I think I may have put it in September. Here we go. Okay, I found it. I thought I did. Moon and Milky Way. Well, I'll share my screen real quick. And so this is an older picture. That's the zodiacal light. And I've taken another photo of that recently from this year, but during this time last year, I got an opportunity to and let's go back here, taking in 2021, it'll be in here. So you're seeing all the types of photos that I take, from people to birds to solar. So not just lunar, but solar. I'll move this over here. And somewhere I have a picture of the moon rising in the zodiacal light. And if I find it real quick, that's fine. If I don't, I will just leave it be. Meanwhile, other moon compositions that I've done that I can show. I will make a point. So that's the original photo. Sometimes you can overdo it with the moon. This moon is entirely too large. It's a beautiful photo, but the moon actually needs to be half, if not a quarter, of the diameter that I actually put it to be realistic. It's still a really cool photo.
It is.
But you can overdo it some. Using the light of the moon, and this was on the other side, is also a neat trick because you've got stars here. If it's dark enough, you'll still see stars in your night photos, but you can get lucky and catch, even with a long exposure, you can catch a wave coming in like this, and moonlight that's hitting the tree. It almost looks like someone shining a huge bright light. Well, that's the moon over there. It's another compositional trick you can do. So those are all, and that's the sun. So not seeing
All
it.
right.
but
Well,
that's
you can
okay.
keep
So
looking for the images that you wanted to show us. Thank you, everyone, for coming. We try to schedule these programs on the fourth Tuesday of each month. And sometimes we have to change the date. We will not be meeting in December, but the next one again is on the arguments, knockdown, drag out arguments over the age of the sun and whether humans really had time to evolve. If the sun was only X number of years old, then there wasn't time for evolution.
the moon when there's smoke in the sky. And that other one was the moon and Jupiter, which I wanted to feature, that I caught at the same time.
Mhm.
And how we know it's Jupiter.
All right, we
There's
have
the band.
I have a question and I don't know the answer.
Okay.
If a light ray has passed in space, it came directly to me. If a light ray has passed in space from a point, and if we put a telescope in the place the light has passed through, do we directly get to see the light source? Or do we have to wait until the time the light, I'm sorry, I this got cut off. The light reaches, I'm sorry, I can't see the last of that
I
question.
think I know. I think the question is if a photon, which is what we call that light ray, is emitted, say light from the Andromeda galaxy or even light from the moon, 8 seconds, not 8 seconds, but a couple of seconds later, a photon comes from the moon bouncing, from the sun that lights it up. Photon ends up hitting the telescope. That photon does go through the eyepiece and into your eye. And the what you see each, when you're looking at an object from space or from anywhere, you're seeing that object as it appeared when it left that source. So when the light left that moon, that's what you're seeing. So, let's suppose you managed to catch an asteroid hitting the moon. You're seeing that asteroid's impact 2 seconds, or however many seconds, light seconds, travels from the moon to the earth. You're seeing it in history. So the actual event, it's kind of like TV where a touchdown is scored and you don't hear about it until the broadcast of the touchdown reaches your ears if you're listening, or reaches your eyes when you're watching on TV. With space, everything is history. Of course, when you're here on Earth, if you're at the game, you see it in real time. You would have to be at these objects in space in order to see them in real time, because of the distances and how fast light travels. You're always seeing something that's historical, even with, if it's the moon, it happened 2 or 3 seconds ago. With the sun, I know it happens to be about 8 seconds. If the sun disappeared, we wouldn't know for 8 seconds after its disappearance. So we would find out, and then, you know, we would deal with it at that point. But here, I'll stop sharing because still haven't found it. But so your telescope is just a magnification object. You know, it just magnifies that light. It's still traveling through the telescope and it's still hitting your eye, but it's you know, it's being magnified so you can see more of its shape, but it's still that same photon that left however many seconds ago. So hopefully that answers the question.
Yes,
Or-
it's far enough beyond me that I couldn't make sense of the question, so I apologize. We're really just talking about photography and the moon tonight.
That's okay. That
Well, but thank you everyone for coming. Thank you, Adrian. Wonderful as always.
You're
We are
welcome.
trying to set our schedule for next year, so suggestions are welcome. Speakers are even more welcome. And I've had someone suggest things that we had no way to find speakers for. And again, my email address is jdye@detroitpubliclibrary.org. Thank you very much. Thank you, Megan. Wonderful as always.
Of course.
And thank you everyone for coming this evening. Thank you, Adrian.
Thank you, everybody.
thank you for having me.
This was great.
Mhm.
Bye.
Bye.
All right. Bye, everybody.